Now, we need to now determine the voltage drop across each of these resistances, R1, R3, R1, R2, R3, R4. We need to determine the voltage drop across each of those resistances. To do that, let us redraw the circuit that has equivalents of these two branches together. So we'll draw it again like this. Earlier, we call this resistance RA, while this is R2, and this is R1. So, and this is a 9-volt supply. This is 9 volts. 9-volt supply now is supplying voltage to these three resistances. So to determine the voltage drop across them, we need to know the current that moves through them. And then we determine the total current passing through R1 and R2 as the total current from the source. That is 0.95 ampere. 0.95 ampere. Now, the current flowing through resistor RA is 0.95 ampere, and that resistor RA does not exist in the original circuit. But the current is divided into I1 and I2 that goes through R3 and R4 respectively. So right now, we need to determine the voltage drop flowing here. So the voltage drop across each resistor. The voltage drop across resistor R1 can determine that as V1. Let's have that one as V1 equals I R1, and that is 0.95 multiplied by 5. That is it. That is 4.75 volts. Now let's say the voltage drop across resistor R2 is V2, and that will be equal to I R2, and that is 0.95 multiplied by 3. That is 2.85 volts. Okay, 2.85 volts. All right, now we are left to determine the voltage drop across R3 and R4. Now, fortunately for us, since these two branches are in parallel, then there will be the same voltage drop across both of them, across the combination of the two. So we need to determine only one voltage drop here. And that we can get by splitting the voltage from these points. That is, the voltage from this point to this position into 2. That's a voltage here, which we can call V3. That V3 can be divided between R2 and RA using voltage divider method. All right, so that to determine V3, we can see that this is supply 9 volts, and resistor R1 has dropped out a voltage out of it. So V3 is actually the difference between the supply and the V1. So V3 equals V, that is the total voltage supplied, minus V1, and that is 9 minus 4.75. That gives us 4.25 volts. Okay, so the total voltage from this point here to this point to the ground is 4.25 volts. So that voltage will be split between R2 and RA. RA is actually the voltage drop across R3 and R4. So we can now use voltage divider method to determine that voltage between instances R2 and RA. Mark you, it's not between R2 and R3, but between R2 and RA. So we have another circuit in place now, which will be drawn this way. Here we have voltage V3 supplying between these points to the ground. Mark you, this is not the voltage source from the original circuit. This is R2, okay. This is R2 and this is RA. All right. So to determine the voltage across RA, which is of interest to us, we use voltage divider method in this manner. VRA equals the total voltage here that is V3 multiplied by RA over R2 plus RA. So this is the voltage divider method. Now the voltage divider method is such that you want to determine the voltage drop across one resistor in a series combination. So the total voltage across the series, when they are two, multiplied by that resistance you are looking for is voltage drop, divided by the sum of the two resistances. And that's what we have here. So V3 is 4.25 multiplied by RA that was calculated earlier. RA is 1.43. So you multiply 1.43 by 4.25 to obtain the final answer. And the final answer is 6.08 volts. This is the final answer for the voltage.